When we think of skin aging, we usually point fingers at fibroblasts, the structural cells in the dermis that lose their collagen-making magic, go senescent, and start spewing inflammatory chaos. And yes, they're major players. But limiting the conversation to fibroblasts is like blaming an entire stadium right on the front row. In reality, the skin is a mosaic of diverse cell types, and many of them, keratinocytes, melanocytes, immune cells, endothelial cells, can also go senescent, each contributing their own brand of dysfunction. Aging skin isn't just sagging and wrinkled. It's immunologically confused, pigmentarily erratic, and structurally unstable. To really understand skin aging, we need to go beyond fibroblasts and start mapping the full cast of senescent characters working behind the scenes. The skin, as the body's largest organ, is a layered battleground between the internal and external world. It's constantly exposed to UV radiation, pollutants, pathogens, and mechanical stress, and these stressors don't just target fibroblasts. Keratinocytes, the outermost cells forming the epidermis, are among the first to absorb environmental abuse. With repeated UV exposure, keratinocytes accumulate DNA damage, oxidative stress, and mitochondrial dysfunction. Many of them enter stress-induced senescence, where they stop dividing and begin releasing a SESB rich in pro-inflammatory cytokines like IL-1 and TNF-A, and proteases that degrade the epidermal barrier. Senescent keratinocytes are particularly damaging because they reside at the front line, disrupting the skin's immune surveillance, weakening antimicrobial defenses, and slowing the turnover that normally keeps the skin smooth and resilient. Melanocytes, those pigment-producing cells responsible for your freckles, your tan, and, unfortunately, your age spots, are another key player. With aging and photo damage, melanocytes can also become senescent. But unlike fibroblasts or keratinocytes, senescent melanocytes don't just stop functioning. They often start behaving erratically. They leak pro-pigmentary signals, unevenly stimulating nearby melanocytes or keratinocytes. The result? Liver spots, uneven tone, and hyperpigmentation that stubbornly resists brightening creams. Worse, some senescent melanocytes display premalignant behavior, retaining UV-induced mutations and resisting apoptosis. They sit in a dangerous limbo between dysfunction and potential transformation, especially in aged, immunosuppressed skin. Then we have the immune cells of the skin, particularly tissue-resident T cells, Langerhans cells, and macrophages. While essential for defense and repair, these immune cells also age. Senescent immune cells can lose precision in their response, secrete pro-inflammatory SASs of their own, and fail to clear other senescent cells. It's a feedback loop. Senescent fibroblasts and keratinocytes create a hostile inflammatory microenvironment. Immune cells try to respond, become exhausted, and in some cases, become senescent themselves. In this way, aged skin becomes a low-grade inflammatory organ, a concept known as inflammaging, with persistent cytokine noise that disrupts everything from collagen synthesis to wound healing. Let's not forget the endothelial cells lining the microvasculature that nourishes the skin. These cells, too, undergo senescence with aging, leading to reduced perfusion, oxygen delivery, and nutrient exchange. Senescent endothelial cells express adhesion molecules like ICM-1 and VCM-1, attracting immune cells and contributing to the inflammatory stew. The result is not just dull, grayish skin tone, it's a structural weakening of the skin's support system that silently accelerates aging from the inside out. Taken together, these senescent populations form what you might call a cellular conspiracy in aging skin. Each cell type ages on its own schedule, driven by both intrinsic damage and extrinsic stress, but once they cross the threshold into senescence, they begin whispering to one another in inflammatory code. Fibroblasts trigger keratinocytes. Keratinocytes rattle melanocytes. Immune cells show up late, confused and tired. Endothelial cells retreat. The youthful dialogue between skin compartments becomes a dysfunctional shouting match. Low-grade inflammation, poor barrier repair, pigment chaos, and tissue fragility. The skin doesn't just look older, it loses its internal coherence. This is why mapping senescent cell diversity in the skin is so essential. Using tools like single-cell RNA sequencing, spatial transcriptomics, and mass cytometry, researchers are now building 3D atlases of aging skin at cellular resolution. These maps reveal senescent subtypes in situ, identifying their secretory profiles, interactions, and neighborhood effects. A senescent melanocyte in a UV damage zone, for example, might have different implications than one in chronically inflamed diabetic skin. Similarly, a fibroblast gone senescent near a blood vessel behaves differently than one nestled under a hair follicle. The payoff? Precision xenotherapeutics. Instead of targeting fibroblasts alone, future interventions could deploy multicellular senolytics or xenomorphics, either systemically or topically, tuned to the specific senescent load of a person's skin. Think of a diagnostic scan that reveals 30% SASP-high fibroblasts in the cheeks, scattered senescent keratinocytes on the forehead, and persistent senescent melanocytes around age spots on the hands. Your therapy could then be layered accordingly. Senolytics to clean up the fibroblasts, SASP dampeners to quiet the keratinocytes, and pigment modulators to reprogram melanocyte dysfunction. Aging is, after all, not a single event but a cellular spectrum, and the skin is the most visible, accessible canvas. We have to study it. By going beyond fibroblasts and looking at the full senescent cell community, we can finally move past generic anti-aging and toward targeted rejuvenation. Not just fewer wrinkles, but better tone, better healing, better resilience, because the more we understand who's talking in aging skin, the better chance we have of rewriting the script.